we map over this array, it should render.
That actually fixes the latency issue.
When several people work on the same complex machine at once, things get messy fast. Parts move, designs change, and if a worker spots a loose bolt, they have no way of knowing who tightened it last or why it was positioned that way. Coding as a team requires a way to track every single movement. To do this, we need to solve two problems: proving who we are and proving we have permission to be here. We solve the first problem with an audit log. This is a running record that lists exactly who touched which line of code, ensuring every change is tied to a real person. Without this trail of identity, debugging is a nightmare. You can't ask for clarification on a specific change if you don't know who made it, leaving the whole team to guess at the original intent. We set up our identity in the terminal, a window where we give the computer direct text instructions rather than clicking icons. Using a command called Git config, we tell the system our name and email address. This stamps your information onto every piece of work you do, creating a permanent digital signature. We can double-check our work by typing git config --list, which shows us exactly what information Git is using to label our contributions. Because we used the global flag, these settings are now active across your entire computer. From this point forward, the mystery of who wrote the code is gone. Now we need a secure way to send our work to GitHub. Standard passwords are a weak link. They can be leaked, forgotten, or intercepted by anyone watching the network. Instead, we use SSH, which creates a secure tunnel between your computer and the server, using a mathematical handshake that doesn't involve typing a password. This diagram shows how the system generates two pieces of data that are mathematically linked. One acts as a receiver, and the other as the only valid sender. We take the first piece, the public key, and give it to GitHub. This is like an open padlock that we leave on GitHub's front door. Anyone can see it, but it only works for one person. The second piece, the private key, stays on your laptop. It never travels over the internet. It is the specific mathematical proof that matches the padlock you left on the server. When you connect, GitHub uses your public padlock to scramble the data. Your laptop then provides the mathematical proof to unscramble it, giving the connection a green light. Because the proof never leaves your machine, there is no password for a hacker to steal, making the connection much more secure than traditional logins. To create these two pieces, we type SSH-keygen into the terminal. This starts the process of generating those unique mathematical strings. The computer will ask where to save these files. Pressing Enter through the prompts keeps everything in the standard folders, which makes it easier for other tools to find your keys later. Now we need to grab the public part. We open the file ending in .pub, which contains the long string of text that makes up our public padlock, and copy it. On GitHub, we go to Settings, then SSH Keys, and click New SSH Key. We give it a name, like Work Laptop, and paste that long string of text into the box. Finally, we run ssh-t git@github.com to test the link. When you see a success message welcoming you by name, it confirms that your laptop and GitHub have successfully performed their first secure handshake. We can now test the whole system by creating a new folder, initializing it for Git, and saving our first document. The moment we save this change, Git looks at the name tag we set up earlier and attaches it to the file, so the team knows exactly who created it. We tell our local project to connect to our GitHub repository URL and push the files. The files move through the secure SSH tunnel we built, arriving on GitHub without us ever needing to type a password. Often, you'll want to write automated scripts that check your code for errors or publish it to the web. If you work on these shipping scripts in your main project, a small error could break the version your team is currently using. To avoid this, we create a branch. This is a parallel version of your project where you can experiment safely without affecting the main work. We use the command getBranch to create this new space and switch into it. Once we finish our automation files, we commit them and push this specific branch up to GitHub for others to see. By setting up your identity, securing your connection, and working in isolated branches, you have moved past the chaos of anonymous changes and are ready to contribute to a professional team. For more guides on streamlining your development workflow, like this video and subscribe.